Good luck.
Madloba. Hello, my name is Sviatoslav. I'm a Frontend Developer. I'm working in Devexperts, Devexpert, Georgia, passionate about coffee, traveling, and today I will talk about Typescript. In our project, we use Typescript, and static types are great, TypeScript are great, but today my focus will be on some examples, on some type errors, and I will try to add some context to these type errors. Our agenda for today, we will start with structural typing, then we talk about type hierarchy, about typecasting, and briefly talk about covariance and contravariance. So let's begin. TypeScript is a structurally typed language. It means that, for example, if we had two types, two objects, the relationship between these two objects will be described by their shape, by the structure. And we can say that it's like, in terms of inheritance, it will be like a parent. Yeah, so let's talk about hierarchy of types. Each type in TypeScript can be represented. Each type in TypeScript has its place in tree-like structure, in type hierarchy. And at its minimum, we can think of this tree-like structure like a tree with only two nodes, with a parent node, supertype, and a child node, subtype. Yeah, so and also we can convert types. For example, when we assign a variable of one type to a variable of another type, we need to cast one type to another. And if we talk in terms of supertype and subtype, we can do the upcast when we're moving from the subtype to its supertype. We can do downcasting when we move in opposite way from supertype to its subtype. We can do it implicitly without any additional description, or explicitly. Let's have a few examples. Here we have example of upcasting. This declaration on the left implicitly got type any, and we infer type string from the string on the right. Also, we can add additional notation for it. It's like the same. In the next example, we got top level type unknown, and we can upcast string to unknown. Upcast is basically type safe operation, and in most of the cases, TypeScript, we will not see any errors. Downcasting. Here we have two top-level types again, and we will try to downcast them from any to string and from unknown to string. Any, it's like the special type. It disables type checking, and it also, we will not have any errors. And the downcasting of unknown will have an error here. Okay, well, let's talk about covariance, but I will start with the example. here we have a logger container. I omitted all of the implementation. So for us, it's a function which takes an argument, a formatter. It's also a function which has string arguments, and it returns union of two literal strings. And then we will try to call it and pass next function. And here is my question. What do you think if will be a type error here? So, any guess? Okay.
I think there will be error because of type of returning type of second function is a string, but we expect literals like USD or gel.
Yes. In the first function, we expect US dollar or Georgian lari, two literals, and string will be like a top level type. It will be super type for these two strings, and we will have a type error here because we're trying to we're trying to convert one type to another, and it's not safe operation. We can fix it by narrowing the type in the call, or narrowing it even more, because we know the return value. Okay, let's continue. Almost forget about our topic. This kind of constraint, we can call it covariance. It means that we can change our type only on exact same type, or type that will be narrower on a subtype of this type, it is covariance. Let's continue with contravariance, and here we will have two examples. First one also will be about covariance, but it's but after that we continue with contravariance. We have two types here, A and B. A is a super type for a B. We declare these two variables here, and we'll try to assign A to B and B to A. And I'm asking you like a second time if there will be a type error, and where.
On the fifth string, I suppose.
Okay, this question is like similar to previous one, and A isn't assignable to B because A is a super type for a B, and it is an example of downcasting, and we can do this implicitly here. Okay, we slightly rewrite our container for the logs, and now callback function looks differently. We have A type, it's like the same type that was on the previous slide. We have A type in a logger container, and we're trying to call it with a B type. I will ask this question, same question again. What do you think? Whether we can do it? I will try to rewrite it like even in like more clear view. So basically, what we're trying to do, we're trying to assign one function to another in terms of types. we're trying to write formatter B to formatter A, like one function to another. It's like the same example, but simplified. Like we got all the types here, and the answer is that B is not assignable to A. Let's look at the last two examples, like on the same page. We have two variables, variable of type A and variable of type B, supertype and subtype. We got two functions with a type A in a value and with a type B. We got interesting situation that in the first case, A isn't assignable to B, and in the second, B isn't assignable to A. But we got same types, and in a different context, they appears differently. In the context of a function that we trying to convert, and when we're trying to convert just to objects. And the second example, we can summarize it like the function arguments can be substituted by the types that are supertypes for the initial type, and this and it's called contravariance. So it's like the opposite behavior to the previous example. And at this diagram, I tried to show this set of rules. At the left, we have subtypes, and contravariance will be we can use subtypes of some type if it's covariance behavior, and we can use exact type if it's invariance, and we can use every supertype if it's contravariance. So I would like to finish on it, and that's it for today.